All right, welcome back to my boiler. Today, though, it's not going to be the front side that you always see. It's going to be the back side, which I don't think I've ever shown. And that's because today I'm going to talk about my hot water loops that I have on my steam boiler, which I have not talked about before because I wanted them to run for a while to make sure they would run before I talked about them, and so that I make sure I knew what I was talking about a little bit before I talked about them. And this is a total DIY homebrew Janky hot water loop. But I learned everything about this from Dan's article on how to add a hot water loop to a steam boiler. And at least I think Dan wrote it, and I'll link to it on the description of this video. But I'll go over the important parts I took from that article. It's a big article with a lot of different details and options, but I will go through the choices I made and why for these hot water loops. I've got a checklist this time of stuff I want to talk about too, so I shouldn't be wasting so much time. But I will start out and say these loops I made for comfort only. Of course, they provide heat to the rooms where they are, but they are by no means the primary source of heat for those rooms. They just exist so that my wife's feet aren't cold, okay? So the first one was in our main upstairs bathroom. I renovated that. It's been like three or 4 years ago. And when I renovated it, I put in Uponor tubing into the floor. So that floor, all the floors in this house, all they were was 3/4 inch pine. And so when I redid that one, I put down an additional like 3/4 inch or 5/8 inch of tongue and groove plywood treated for the floor. And then on top of that, I put the Uponor Fast Track. I think it's called Fast Tracker. That's what it used to be called. And that's this, what is it? It's like it's roughly 1/2 inch, maybe a little less than 1/2 inch plywood with these channels cut in it that can hold their 5/16, I believe it is, their 5/16 PEX loop tubing, which is right up here. Okay, so I run it in my basement. I run it up to the floors. That was the first one. That one is on, like I said, the second floor. So from down here where the pump is, it's like 7 feet to the first floor line, and then it's another roughly 9 feet or so to the second floor. So what does that add up to? 7 plus 9, like 16 or so feet higher than this pump. And I'll talk about that shortly too, but it's totally cool. You can run a hot water loop higher than your boiler water line. And let me cross this item off. I'll try to talk about that next, I guess. In the article, it goes into great depth talking about how it's possible to run a loop that uses the boiler water directly. There's no heat exchanger here. There's no separate system. This is all the open steam boiler water that I'm running to heat these floors. How can you run that, 16 feet higher than what your boiler, well, not quite 16, but you get it, 15 or so feet higher than your boiler water line? How can you do that? Well, the answer is these loops, topologically, if you had a U-shaped tube, right? I'll do a demo of it. That's what I'll do. You have a U-shaped tube and I'll cut away and show it, right? But a U-shaped tube in a bucket, and you submerge the tube, you lay the tube down, right? So it completely fills with water inside the bucket. And then you lift it so that the top part of the loop comes up while the two legs of the U remain under the water. You could lift that up, and then you could lift it up to something around, what is it, 30 feet, something like that. Because it gets a little complicated, right? But the barometric pressure is pushing on the water in the bucket, and when you lift this thing up, you don't allow any air to enter that U, so the water comes up with it, right? I'll show a demo of it. And you can only go like 30 or whatever feet, and it depends on your elevation and what your barometric pressure is, because once you get higher than that, the water will start to vacuum. It'll the weight of the water in those legs of that U shape, they'll be pulling down, right? And they'll actually cause a vacuum, or they'll crush the if the pipe is PEX, and I don't know if PEX crushes when this happens or not, but one way or the other, it's going to fail. But as long as you're below, whatever, 28, 30 feet, whatever it is, then you're good. And the circulator can do the work of circulating the water up that height. Because even though you think, it has to push it up through that much head, right? It has to push up 15 or 16 feet of head. Well, no, it doesn't, because on the other side, the water is coming up over the top of the loop, and it's falling on the other side, so it pulls and it helps it pull. So this system is totally open. You don't need any pressure. There's no pressure on this side. Okay? In fact, it's negative pressure. Like I said, the higher you go up in this loop from this level, the less the pressure becomes. Anyway, read the article. He tells it like 3 different times because he understands that people don't get it. And people definitely don't get it, all right? And I had to read the article a bunch of times too to think about all this stuff. So I wanted to go to a totally open system because it was easier, and because this is a Janky DIY home-built system, right? I didn't want to deal with I would have had to deal with a second circulator. It's like it would become like an indirect, right? I'd have to have a second circulator, and I'd have to have a heat transfer plate or whatever to get the heat from this loop here of the boiler water out to this loop. I didn't want to deal with all that. I just thought, I'll just try it, okay? So I did, and it works. And I'll explain more about that. So let's see, what else? What did I talk about? Yes, I talked about I'm circulating the boiler water. It's based off of Dan's article, linked in the description. It's Janky. Okay. The next thing I'm going to talk about is the bypass loop. So let me show you. Step over here. Let me show you what this thing is doing. So here's the boiler water, right? It's like 212 degrees often, because this thing's coming, it's winter time now. So this thing comes on like every hour or every couple hours. So this water is pretty hot all the time. So I got an aquastat for it, but I never hooked it up because I realized, oh, the water's always hot in the boiler, right? Because it's winter. The boiler is coming on periodically, so I never really care. And because this isn't to heat rooms, it's just to heat my wife's feet, it doesn't matter if this is, what exact temperature this is. It's going to heat the floor, and it does heat the floor. So the water comes in here. I've got a metering valve here and a metering valve here. This is the bypass loop. So I'll show in a second, I'll show like what the loop part is. But for now, just consider that what's coming down through here is water that's already returned back from the hot water loop. So it's water that's cooler than this water. And you adjust these two in order to get the right mix so that you get the right temperature coming down through this part, through the circulator, and going up to the loops, which again, I'll show you in just a second. Now in Dan's article, he implies you can get away just with this one, I think. He says you put a valve on the bypass loop and basically you run the bypass loop full open, which means the water will be just it should just be the loop water circulating, right? And then you slowly close this until you get the temperature you want and you get the right mix of the boiler water with the loop water. Well, I found that didn't work, because even when I had this fully open, a lot of boiler water came in anyway. And I'm not into fluid dynamics, but if you imagine this cycle here, if it's coming around like this, I do think it tends to cause a draw here. It creates like a little vacuum because the water's flowing through here, and I believe it wants to pull it. So I had to add this valve after the fact, after I tried it, to pretty greatly limit the hot water that was coming out. Now, why do you have to limit the hot water that's coming out? Well, you don't want this to be 212 in here, right? It's too hot for the floor, right? I don't want to burn my wife's feet. I don't want this whole loop to be 212. But also, if you try that, what you get is cavitation or flashing to steam in the circulator. And I think I can demonstrate it. So just for fun, let me open this up a little more to make sure some good, nice boiler water can come through here. And let me close this up and see if we can get it to hammer. Okay, I closed the bypass. So it should be pretty hot water. I got it, it did it earlier. See, I've closed the bypass valve, so now it's just boiler water coming in. Well, it was doing it. Oh, there it goes. Let me crank up the pump a little bit and see if that helps. All right, well, let me try throttling the boiler water too to try to get this to happen. Probably burn up my pump. Oh, here it's making noise. Huh. Yeah, it's okay, it's making noise. Well, it's funny, it was hammering before. Like it was going tink, 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 tink. That's my impersonation. It was hammering, and what I think it was doing was it was getting a vacuum here, or the water was so hot that because there is a vacuum here, because it's pumping, there's a vacuum on this side, or less pressure on this side. It started hammering with these little tiny pings of hammer that were happening, and I don't know why it didn't do it just now. I tried to make it do it the same way it did it a few minutes ago. But that's the way it works. Sometimes it doesn't do what you expect. So you don't want that to happen. So you don't want super, super hot water coming in here. So let me show you what happens after the circulator. So just know that a mix of the loop water, which is a little cooler, because it's gone through the loop already and given up some heat. A mix of the loop water and the boiler water enters the circulator. It comes up here. I'm gonna come around this side. Here's where I put, this is the Uponor distribution manifold. Is that what it is? It's a manifold, right? Yes, and you can see it enters down here. The temperature, this is hotter than I normally like it to be, coming in at 130. It's because I messed with the valves just now, right? So hotter water is entering the loop. It comes in here. One loop goes to my bath, That's upstairs. And then one goes to my living room floor, which I don't think I mentioned yet. But a couple of years ago, I put staple up, and I posted about this on the site on heatinghelp.com. Was it also Uponor? Yeah, it was Uponor's stapled up extruded aluminum pieces, which I'll show you in a little bit. That's for the living room, so that keeps the living room toasty. Now, just this summer, like I said, okay, all my floors were just 3/4 inch pine directly on the joists. That's all they were. But this summer, I put down like a 1/2 inch plywood on that living room floor, and then 3/4 inch hardwood I put in on that floor. And I made sure the nails weren't going to come through and pierce my my pecs, and they didn't. But now this year I've got to find out how the heat transfer is, because through 3/4 inch of pine, the heat came pretty nicely up through the floor. But now it's got to go through, you know, more than double that of additional wood. Not more than double additional, but more than double total thickness of wood. So we'll see how it does. I might have to bump up the flow rate on that one compared to the other one. And this Uponor manifold is really great. It has these flow rate meters, so you can see here it's flowing at about 0.6 gallons per minute, and this one's maybe a little bit more on this loop. And that's adjustable. If I turn this, that was full open. If I turn this, you'll see it goes up. See that? So I reduced the flow rate there. But I don't really meter them much. I keep them both full open, and it's fine. So it goes here, it goes up to the 2 loops, it comes back down from the 2 loops here, and goes into this side of the manifold. You can see it loses some temperature, which is totally expected. So right now here, okay, it's dropping back a little bit. So it's like 125 going in, and it's like 115 coming out, 114 coming out, which is pretty good. You know, if I needed to control it different, I could. But that's how that works. I highly recommend that Uponor manifold system and their PEX tubing and everything. It all just works really good. So I talked about that. Okay, this circulator I want to mention real quick is a Grundfos, whatever. I think it's the Alpha. It's the one that's got, oh, let me put the speed back down. I always keep it at the lowest speed. It does fine. It's got 3 speeds. Hear how quiet. You can barely hear it. I'll turn it off real quick, see if you can even hear it. I'm holding the microphone right on here. Okay, there's off. Here's on. I'm going to turn it on. Okay, you can hear it a little bit, right? Well, this pump, if you know, is cast iron. And you're supposed to use, if you use the boiler water as your circulating water, you're supposed to use a stainless steel or a bronze pump. And the problem is those pumps cost 3 times what this cast iron one does. At the time I got this thing, I don't know, it was like $100 or something. So I was like, well, I'm just going to try it, because even if it fails, I can buy 3 of these for every one of the other pumps. And I just wanted to try it. Well, it's been 3 or 4 years now, and this pump just runs. It runs and runs. And I keep it, you know, I keep it with all the water in it all year round. I just don't run the pump during the summer. And everything's fine. Now, I do try to keep my boiler water really clean. And it's a little bit, you'll see it's a little cloudy right now. That's because I messed with these valves, and it pulled way more boiler water into this system than it normally does. And I just learned this trick from someone else on the forum. I put these magnets here on my sight glass, and you can see they're collecting rust. So that was because all the last couple of years when I've run this water remained very clear. It's only because I was messing with the metering today to get things ready for my demonstration that I started pulling in some brown boiler water was hiding somewhere in my boiler, and it got pulled into my loop. But I do have a Y screen on here. I didn't clean it this year. I cleaned it last year and it was clean, so it hadn't really caught anything. And as you can see, it doesn't catch this type of stuff anyway. It just catches big chunks, but there's no big chunks in my boiler. You know, as I talk about all the freaking time, you're all sick of hearing me talk about the pH level in my boiler to try to keep it clean and not very rusty. But you can see I do get some rust, but it'll clear back up. This will clear back up again because when it's normally running, it's just sipping the hot boiler water into the loop to get that temperature back up, to gain back basically the 10 degrees that I lose in my floor. Okay, so that's the story of the cast iron pump that's supposed to, basically everyone will tell you, like, don't ever use cast iron on an open system, blah, blah, blah. Yeah, it's fine. You can use it for quite a while. I don't know when it's going to fail, but I'll tell you when it fails. And then how do I control this thing? Well, if I'm lazy, I just run this thing 24/7 and keep the floors, keep it circulating all the time. But it does, of course, pull heat, out of my boiler. And if there's no one up there to keep their feet warm, what's the point? So I put a smart outlet on the pump, and I use Apple's home system, okay? But you could use Google or Alexa's, the Google or the Alexa stuff the same way. And you just program an automation on this smart outlet, and I just have it turn on, like at 5 a.m., I have it start circulating. And then, my wife gets up at 6:30 or 7, and the basement floor is warm. The bathroom floor is warm for her, right? And then when she comes down to the living room and she's having breakfast or whatever and getting ready for work, the living room floor is warm as well. So that's how that works. And then I turn it off. When she goes to work, I turn it off. And then when we go to bed at night, it's set to turn off. So it just turns itself on and off periodically. That's how that works. I talked about that. I talked about how I'm not using the aquastat because there's always heat in the boiler anyway. It's fine. Again, I'm not heating the room with this. Although I did remove my radiator out of that bathroom. But where I removed the radiator, I insulated that hole, and I insulated the rest of that exterior wall because I was doing a renovation on that bathroom, as I mentioned. So that bathroom stays pretty warm, even though it has no radiator in it anymore. So the floor keeps the toasty on your feet, and it does add some heat to that room, so it's good. Okay, here's one I can talk about, a topic. You'll notice the circulator is all the way down here on the floor. And I think Dan's article talks about that too. I don't think I was smart enough to come up with this, but it makes a lot of sense. So here's the tapping on a Peerless that you can use. And I could have used this one too. This one's a little higher. This is a 1-inch tapping, and there's one on the other side over here that matches it. So it's meant for this. It's meant for running a loop, either directly into whatever you're doing, like I'm doing, or you could run it into a heat exchanger with a circulator pump. That's what this thing is for. It's for that purpose. Some boilers have a handy place to do this, and some don't. You don't want it all the way down at the bottom, like where the drain is, because it's going to be pulling mud out of your boiler for sure. You want it a little higher. That's why Peerless put it a little higher. It could be even higher yet, but they didn't do that. And they're trying to think if there's a reason for that. they might have wanted to force you to have a certain amount of head. So the water line is up. They probably wanted to ensure that this would always be below the water line, right? So the water line is somewhere around here. This has got to always be submerged. You don't want this sucking air, right? And getting air bubbles in here and then having the pump, you know, get airbound or whatever. You got to keep this fully under the water line. So that's why they picked that level. Then the circulator, you want it as low as possible because you want to take advantage of this head here, this distance, this vertical distance here. It goes horizontal here, and then this vertical distance here, it's like 1.5 feet, right? But it's 1.5 feet this distance, and then plus whatever it is, like another 0.5 foot, 8 inches or whatever to the water line, so that you get a couple inches of head. Right? That's what they call it, right? Or basically water pressure, water pushing, the weight of the water pushes down here. Again, because you don't want this thing to cavitate, and you don't want it to, the water to flash to steam. Those are similar sort of concepts. The cavitation, I think, happens easier if the water is close to steam temperature. But you don't want that to occur. You want this just all remain nice water, right? Water, 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 and then it's water all the way up and water all the way down. And then let me show you this part. On the bypass loop, you need a way to get rid of excess water. So when water comes in from the boiler into the loop, you want some cool water to basically be able to bleed off. And this wasn't really this way in Dan's article, but this is the way I ran it, and it worked, so I kept it that way. So this can get pretty warm, you know, over 100 degrees, but it's not too hot for the PEX. The PEX is fine. It doesn't melt. And then that runs over, you can see it runs over that way. It runs back to my wet return is where I ran it. Because there's a thinking in Dan's article, I don't know if I really agree with it, but there's a thinking that if you have a boiler that doesn't have these nice extra tappings like the Peerless has, right? Let's say you just have this one here, just a single tapping here, right there. You don't want to use that for your supply and your return because the cool water will come in and then get pulled right back out again, and you won't get the benefit of the nice hot water that's in the boiler. Now, I kind of think when you put water back into this hot boiler, it gets pretty hot. I mean, the guys who have real experience with these things, they probably know better than I do. Sometimes they don't. What can I tell you? To me, if you pour water into a hot boiler, it's going to reheat. You know, the castings are all 212 degrees. It's not like there's different sections in there. It's not like it's just, you know, a big open pool. I guess if it's going into one section and coming out of that one section, you could cool off that one section, I guess. But anyway, the way I'm doing it, there's no danger of that. You're pulling fresh hot water from this part of the boiler, and you're feeding the cool water over into the wet return side. So definitely the water's getting all mixed up, which is good. But you have to be aware of that. And he talks about some tricks you can do. If you only have a single port like that, you can still make it work by running an interior pipe inside there so that it's like a dip tube in a water heater, so that it runs in there farther and pulls, you know, fresh hot water out and dumps the cool water, you know, there. So I hope that made sense. I was rambling a little bit. What can I tell you? I talked about cavitation, the head, and the Peerless tappings. I talked about how the loops are elevated well above the boiler water line. And like I said, I'll try to do a demo of that to put on the back of this video. I think that would be kind of cool. But one thing that I made it easy on myself is there's no fittings. Each of these loops is a single loop of PEX. And I bought them, what were they, 100-foot loops I think I bought from Supply House. Obviously it's not going to say on here what the original loop was before I cut it, but I think it was 100 feet. I had just enough on the bathroom one, I had like a 1 foot left over, which was perfect, which was great. And then the living room one, I might have ordered that one longer. I can't remember. Maybe that one was 300 feet, and I cut it. I had quite a bit left over on that one. Let me show you where this one goes. So this one, I run it up here. I don't bother insulating it. It doesn't get that cold in my basement, and I figure any heat up here is going to rise and go up into my floor joist bay and tend to warm up my first floor a little bit. So I didn't bother with insulating it. So you've seen these pictures before, perhaps on Heating Help. These are extrusions, and I screwed them with little screws to the bottom. They're quite warm right now. That's good. You know, they're probably 100 and 110 degrees, I feel right now. I should get my thermometer, but who cares? Trust me, it's warm. So each of these bays has them up to this one, and that's the last one I did, because that's where the living room ends. So it's these several bays here. I didn't do that one because it's under the couch. So there you go. So it's just these loops, and then it comes back here, meets up with its buddy, and returns all the way back here to the manifold. That's it. And it works. My wife is really happy with this. I put off turning it back on this season for no real good reason, and she was bugging me about it several times a week. She was like, hey, when are you going to turn the floors back on? So she loves it. It was really cheap. I did it myself. I said that a bunch of times already, sorry. It was super cheap to do it, and just uses a bunch of heat that was already just sitting in the boiler anyway. You know, again, it takes some heat out of the boiler, but the boiler heats the boiler water up to 212 super fast and easy. It doesn't, well, you know how many BTUs it takes, right? Pound of water, 1 degree is a BTU, right? So this thing's got 9 gallons a pound, or 9 pounds per gallon. So like 80 pounds of water are in this boiler. So to raise all the boiler water 1 degree is like 80 BTU. So to raise it 10 degrees would be 800 BTU. This boiler does that really fast. So whatever it cools down in between boiler cycles, it's no big deal. I've never noticed any serious difference in the amount of time it took to make steam or anything like that. So you can see this is getting clearer again. It'll clear out. You can see there's some of this color is the 8-way that's in my boiler. I had this with no color marker last season. I had just used, what was it? Sodium hydroxide, is that it? Lye? I can't remember the name of it. I had used lye to increase my pH to around 12 or 13, and I wasn't using 8-way. Well, this year I decided, okay, I'm going to go back, I'm going to get the pH back down to like 11 or so. Some of the knowledge I saw said that higher than 11 or 12 could start to actually remove the protective oxide coating that's on iron. And who knows, maybe that's what these guys are. But anyway, that's where I'm at. Because this circulates with the boiler water, whatever is in my boiler water will diffuse with this, and it all becomes one single supply of water. So that's it. And I guess next I'll do a demo of why this loop works. I'll try to find some tube that I can do a demo of that. All right. Thank you. That's it. Well, it's not it. I'm going to show the demo next. Okay, here's my demo. I have no idea if this is going to work, but you can see I got a bucket full of water. I clamped one end of the hose, the tube rather, underneath the water line, okay? And then that tube goes up here, goes up this high, so about 6 feet high. Well, only 4 feet above this water line, right? Something like that. Comes up here, and then it runs back down, and it's in my hand, okay? So what you have to do is you have to fill the entire tube with water, right? There can be no air in it for this to work. And when I do this, I assume there's going to be some air remaining in it. And I'm going to have to use that as a demonstration of what you don't want to have happen, okay? So I didn't mention this. I forgot to, but I'll mention it now. I took my spigot, well, it's probably this one. I took my spigot here, and I hooked a hose to it, and I ran it over here to where my loop is. And I have a double female side, washing machine, old washing machine hose here that I hooked to the hose. And it's set up, the Uponor manifold is set up for this. This is flushing, right? So when you set up the loops, you close like one loop here and here. You can close the loop completely off. You can isolate it. So you close one loop, you leave one loop open. You have the hose going here. And in my case, normally you could hook like another hose here, right? So you run water into this side, and it runs through the whole loop, and it comes out the loop and squirts out here to like a bucket, right? In my case, I think I just ran it, I let it run into the boiler because I didn't care. But you force water from your domestic water supply through each of these loops one at a time in order to get all the air out, or almost all the air out, and just enough so that the circulator will be able to take over and start pumping it. Because if you just try to run the circulator with these full of air, the circulator does not have enough power or head, if that's the right word when you're talking about the circulator, I don't know. But it can't lift the water all the way up that height, right, by itself. You have to pre-fill these loops. And it's the same thing with a hot water system, right? I've never worked on a hot water system, but that's my understanding. You get the same issue with the hot water system. You got to flush all the air out, or again, almost all the air out. There could be still some small bubbles. In the case of a hot water system, it's a closed system, so you got to get those air bubbles out of there. In my system, it's open, so the air bubbles will tend to work their way out. Little bubbles can get pushed out of this system, and they end up going into my boiler. And then when the new water comes in, it comes in without the bubbles. Of course, it's an open system, right? So there's going to be some oxygen in there, but you don't care. It's an open system anyway. It's not like this is just PEX. It's not going to be hurt by a little oxygen in it. The reason you don't want it in a hot water system is because it'll corrode your steel in your system, right? Your pipes. This is just strictly PEX. It's already in an open system. That's another beauty about it. I don't care if a little bit of air, it doesn't get in there because everything's under the water line. But if little air bubbles come in from the boiler water, right, and they come in here, they'll just go through the whole thing and they'll come out the other side. It's fine. These are completely full of water. If they weren't completely full of water, you wouldn't have this flow rate. Okay, so let's go back and let's see if I can make this work. I'm going to get soaked is what's going to happen, so you all can laugh at me. I'll just try this. See if this is going to work one-handed. Okay, look, the water's going up. Water's going up. There we go. Oh, see, it leaves a little air bubble because the water's not on enough to get rid of that little air bubble, right? But if I run this now, yeah, see this, it's all full of air. So this is not a really good example. How can I make this be a better example? Let me pause this and think about this for a second. There's got to be a way. Okay, I did it like a siphon. I pulled a siphon out of the bucket down below here on the floor into another bucket, and I got the tube completely full of water. So you can see it's totally full of water. There's only a couple very tiny bubbles in it. So now I'm going to get another clamp, and I'll show you basically the equivalent of one of these loops, what's going on with it, okay? Why you can pull it higher than the water line and everything works. So let me pause the video. I'll be right back. All right. So I went and got another clamp. It's clamped up here. It's not pinched off, okay? It's open tube. The water is in here. You can see how it's magnifying my fingers, right? There's water in the entire tube. It's well above the water line of this open bucket. This bucket represents my boiler, right? The ends are not sealed. They're just open. There's one. There's the other. They're just open there in the water. But there's no way the water is heavy. It wants to pull down, but it can't because there's no way for air to get in to take the place of this water, right? So this water, it's under, the pressure here is like atmospheric pressure. But then as you go up, the pressure gets lower and lower and lower until the point when you get up to like 30 feet, then this is going to fail. This tube would fail before that, I assume. I assume what would happen is this tube would collapse, as you got high enough to where there was enough weight pulling down that then the atmosphere is always pressing on this. And if the water is pulling away, it's going to allow the atmosphere to collapse this pipe, this tube. So now, here's why you can't allow, let's see if I can do this one-handed. Okay. What I'm trying to do is, I'm going to mess this up. I'm trying to show, there we go, okay. Yikes. So both ends are under the water. This is why it has to remain under the water level of the boiler. Because if the boiler water goes down, see, check this out. You see this? If the water level goes down, then this is going to allow, see that? It allowed air bubble to go in, and I lost it. The whole thing emptied that quick. So as soon as one of the ends comes out of the water, then the other side is going to pull, and air is going to go in and fill your pipe or your PEX or your tube, whatever you got going, and then you got to run the water over to the system and refill it. So the way mine is set up, it never has done this. It's never allowed any air into the system because the tap point here is well under what the water line in the boiler ever gets down to. In fact, I keep my water line quite high in this boiler, so that helps even more. But as long as this side remains underwater and this side remains underwater, which it does, it's over in the wet return, then no air can get into the system and it will circulate. And it's always circulating as long as the pump has power on it. So that's how it works. And this is really the end now. I hope that demonstration helped. It's not easy to understand it until you see it sometimes. And like I said, I had to read Dan's article like 3 or 4 times all the way through to understand all the different things he was talking about in there, because he did talk about a lot of different details and a lot of different subtopics about running a water loop. If you want to know more about it, definitely read his article, which again, I'm going to link to it in the description. All right, that's everything. I'm all done now. This video is way too long. Sorry. Bye.